some chemical changes require energy. It might be in the form of heat or light or electrical energy in order to proceed. Heating mercury 2 oxide will cause it to break down into liquid mercury and oxygen gas, as can be seen here. Your book mentions sugar breaking down into carbon and water when it's heated. As mentioned previously, many elements exist naturally combined with other elements to form compounds. When these elements are needed in their pure form, the naturally occurring compounds have to be collected and then forced to break down. We don't find aluminum as a pure vein of aluminum inside of a rock face. We find aluminum oxide, and we mine the aluminum oxide, and then we have to get it to chemically break down to form the aluminum that is part of the aluminum oxide compound. Sometimes compounds must be created by reacting elements with other elements or with other compounds, etc. Ammonia is a compound composed of nitrogen and hydrogen. Its formula is NH3, shown in this ball and stick model. It's used by industries for refrigeration, as well as by farmers as a fertilizer. Animal excrement is a natural source of ammonia, which is why it is frequently used as a fertilizer. In nature, most silicon is combined with oxygen to form silicon dioxide. Silicon dioxide makes up sand, flint, quartz, and opal. Silicon is also found combined with metals, such as iron and aluminum, imparting different colors. When silicon dioxide contains small amounts of manganese or iron, it forms a type of quartz known as amethyst. It's purple in color, and it's frequently used as a gemstone. So when we're distinguishing pure substances from mixtures, we know that we can break matter down into two categories. It may be a substance or a pure substance having a definite composition. It would be homogeneous. That means it's either going to be an element or a compound. However, compounds can be separated chemically into simpler substances known as elements. Here's some examples of each of those. Or instead of being a substance or pure substance, it could be a mixture of substances which vary in composition. They can be separated physically to give you pure substances, which we've talked about before. There are two types of mixtures. They're either homogeneous mixtures or heterogeneous mixtures, depending upon whether they have distinct parts from one another. And here's some examples of those. Most heterogeneous mixtures are easy to distinguish because they have visibly different parts, with the exception of suspensions. However, homogeneous mixtures, as well as pure substances, elements or compounds, both are homogeneous. They have uniform composition, so there are no visibly different parts, even at the microscopic level. That makes them difficult to distinguish from each other. Determining whether something is a homogeneous mixture or a pure substance, an element or a compound, can be difficult. One general rule to follow is that if the composition of the material can vary, then the material is definitely a mixture, such as milk. Milk comes in different varieties: skim, whole, 2%, 1%. Gasoline, same thing. They have different octane ratings. Remember that a mixture can be separated into its parts by physical processes, which we studied in Section 2, things like filtration, distillation, and evaporation. So now let's try applying what we've learned about these to a problem situation. We have a blue-green solid here. It's heated, and as it's heated, a colorless gas and a black solid forms. All three materials are pure substance. So, is it possible to classify these substances as elements or compounds? What do you think? So it says we know all three are pure substances, okay? The original substance broke down upon heating. So that means it broke down into simpler substances. So the original substance had to be a compound. Now, in the process, it created a colorless gas and it created a black solid. Do we know anything about the gas and the solid? We know it's a simpler substance, but whether it's a simpler molecule or formula unit of a compound, or whether it's a simpler substance that's an elemental substance, cannot be determined from the given information. And our final example, a clear liquid in an open container is allowed to evaporate. After 3 days, a solid is left in the container. Was the clear liquid an element, a compound, or a mixture, and how do you know? Well, what do you think? That liquid that we started with, after evaporation, the container still contained a solid that wasn't visible before. that means that solid was originally dissolved in the liquid that has evaporated off, which means the clear liquid we began with was definitely a mixture. It was a homogeneous mixture or a solution where a solid was dissolved in a liquid and there were no visibly different parts. Thank you for listening.